a lot about what we did in Amazon, how we scale things at Amazon, how things were different, and how the architecture should look like when you're thinking of big data. And that's where I'm going to cover a lot of examples from my past experience also, and share how we design the actual solution at Amazon also. So it's not just training, but also want to give you the solution hat onto your onto this training session where you can think differently, understand what is the best architecture used in the industry with companies like Amazon, Google, Microsoft, and then we'll keep moving and learning AWS as well. So as Ashish said, I really want this session to be interactive. It's very difficult to be on call, not be able to see you guys and understand whether you're getting the topic or not. So I request you, be vocal. Let's keep it interactive. You can stop me at any point. It doesn't mean that we have to take questions at the end of this session. Keep it interactive. If you don't understand a topic, we'll pause that, discuss, brainstorm, and move forward. Hope that's clear, right? So this is the agenda that we are being going to cover for this training session, which is going to be for the next 10 days, 2 hours every day, as mentioned. It starts with very basics of what is cloud, why cloud, right? You already have a data center which has all the
We can't hear you, Nathan sir.
yeah. Hi guys, can you hear me?
Yeah, yeah.
Yeah, sorry. So I had a power failure. Just went to the backup. So I'm sure we were at this point of time, right? Agenda. We're discussing the agenda. So what's cloud? Why cloud? So we'll discuss that, and then the overview of AWS. So the first topic is what we'll be covering today, where we'll discuss about VPC, subnet, EC2, EBS, load balancer, how things, what are the building blocks of AWS. That's what we are going to cover. And understanding this is very critical and crucial because they form the base of how things work on AWS. Then we will be moving towards overview of big data, which is SDFS, High Scoop, Spark, and many other tools in the big data space. I'll talk about data lake and design pattern. I'm sure you guys would be interested to understand how data lake is implemented in today's world and how we have designed data lake at Amazon. That's where briefly I'm going to talk a lot about how things look at Amazon inside Amazon, how we did the data lake and the design patterns. It's a huge topic, but yeah, I'll try to cover that because that forms the basis of what the architecture is going to look like. Then we get into the AWS data engineering space where we'll be talking about S3 and then EMR with Spark. I plan to include Databricks also, and I'll give you the reasons which I've not highlighted here, but I'm going to give you those reasons as well why Databricks. Then AWS Glue, it's a catalog and ETL tool. Then Redshift, which is a massive parallel processing database, very powerful database on the cloud. AWS is, I think, has moved into the data warehousing space using Redshift a lot. And we'll talk about Athena, which can be good for data engineers, good for data professionals who are specifically only writing queries on data lake, or even for a business analyst. Then the real-time data processing, it's not about batch, but now the world is moving toward the real-time data streaming and processing, so we'll be covering that area. And of course the most important part is the visualization, which where we'll cover one of this quick site of Power BI as a tool. And yeah, based on what your organization is using, I can help you. I have worked on all the three, so I can give you details, what are the best things to do, how to design things out. We will cover that as well. And finally, the most important thing is what are the best practices on the cloud and how do you optimize the cloud, right? So cloud starts small, but yeah, you always start hitting a lot of cost on the cloud if you do not know how to govern your stuff on the cloud and how things should be optimized and well planned. So I'll stop there. uh, guys, any question? How do you like? What's the reflections on the agenda?
And Nitin, like few of us, like we don't have background with big data, so
So can you be a little loud? It's very difficult to hear you.
yeah, can you hear me?
Yeah, it's a little better. Yeah.
Yeah. So what I'm saying, like few of us actually we don't have any background with big data, so we have like different background like SQL Server and like
Mm-hmm.
on-premises databases. So it
Yeah.
would be good like if you can relate, while going for any topic explanation.
Perfect. That's a really important feedback. That means I'll be little deep onto the overview of big data. That's what would help you understand the concepts. Okay. And I'll keep
Yeah.
relating back to the database here because I have moved in the same journey. I used to, as I said, ETL engineer working on on-premise RDBMS databases like Oracle SQL Server, and then in the last 5 years I moved to this technology. So it's very easy for me to relate what you are going through. Any more feedbacks? It's a really important feedback. The feedback really helps me focus on specific areas and move fast on specific areas, and that's where I want your feedback in this session. So I'll be covering based on what you really need. As Ashish said, this is your session, so please be vocal and talk about it. So anyone with the background of AWS before, who already understands VPC, subnet, EC2, EBS, load balancer, or different services, or you guys are new so that I can yeah take right from the basics of cloud as well. Okay, so I guess we all are new to AWS, right? And I understand that your company does have an AWS account, and it's you guys are going to move into AWS sooner or later, right? Is that understanding right? Hello.
As of now,
Oh,
like we just like going to start with the AWS. So most of
mhm.
us did not work, so we have very little exposure. Nitin, to just help us.
Okay, that's cool. Okay, then I think this agenda sits perfect because that's why I'm covering very in depth of what we are going to talk and covering those different services also. So I understand my audience well now. So let's get started. So what is cloud and what is the bus? So the cloud refers to the servers that are accessed over the internet and the software and the database that are running on that those servers, right? So what does really cloud mean? Cloud means it's on the internet, to be very simple. And that's how you would understand cloud to be. So the different services like google.com or amazon.com, these are all services and hosted on the cloud. It means all you need is an internet, and you get connected to the internet via routers, and you're able to access them. Now, why enterprise are moving to cloud? Because cloud has different data centers which are across all the world. So let's take an example, right? So example, you started a very small company like Uber, which just kicked off. You started launching your cab service in US, and then you saw, okay, you got a lot of customers and there's a buzz and you want to move to different regions. Now setting up a data center can take 3 years, right, for a larger organization. So example, if Uber says, okay, let me go and start my operations in India, it'll take them 3 years to build a data center, get the government authority, get the location, the real estate, powering up the data center, everything, right? Security. Now, why cloud? Again, the greatest advantage is with cloud, the data centers are already there across the world. So Uber just said, okay, let me launch in India. I'll use AWS and I'll use the Mumbai region of AWS, which is one of the regions in AWS. So it will be talking more about it. And for a startup, it's a boon because you can move to different locations of your globe and get up and running in next 2 days, rather than waiting for the next 2 years or 3 years of that data center to be formed. So and also there are a lot of other advantages of cloud, like scalability, right? So cloud provides you a server which can scale on demand, which will be one of the sessions that we are going to talk about. And if you see on the right hand side, uh, AWS has many things, and it provides you 360-degree of solution for any of your services or any of the solutions that you need on the cloud. So it has servers which are related to, like, you can have a virtual machine, you can have a big data server. It has solutions to network, it has solutions to storage, something like S3, which we'll be discussing in this training. Remote computing, you can connect your mobile device or build mobile applications. You have email services, you have security by default on AWS for every service that we talk about. So you can develop web applications, you can process big data, so you can process big data jobs. So AWS is a public cloud, and that there are three leaders in the public cloud today. There are many, but the leaders are three, which are AWS is the number one leader. Then we have Azure, and which is from Microsoft, and we have GCP, which is from Google, right? So the cloud, the bigger advantage is you get a lot of agility, which is like speed to build application. You get all the tools so that you need to worry only about solving a business problem rather than thinking of taking care of your infrastructure. And you also can be smart in moving across the regions, as I just said. And that's what we are going to cover, how AWS helps you out. So as I said, you can always pause me if you don't understand, and we'll take questions. Okay. Else I'll just assume that, yeah, everyone is clear, and I'll be keep moving forward. So please always be vocal and stop me if you don't understand or if you have a question. Service modes for cloud. So cloud started very small. If I want to give a background of what happened in Amazon, right? So around 20 years back, it was what we used to do in Amazon was you had see any developer who joins the organization, right? So what they will need is they need a laptop to do the development, and you might need a virtual machine also, so that you can write your code and post your code and build your application, right? That was exactly the requirement for any engineer joining Amazon also. So the problem with what people used to face in Amazon was it was growing so rapidly. Many engineers joining the company, they wanted access to virtual machines. Now, when you give access to virtual machine, it used to take like 3, 4 days, 5 days for him to get an ID, for him to provision a virtual machine, give him access to the virtual machine, and all those stuff, right? So that was frustrating because Amazon was growing so fast, right? And they had engineers, hundreds of engineers joining every day. That was an internal project by one few sets of engineers who decided, okay, let's do this. We'll create a on-demand virtual machine website. All you have to do is log into the website and say, okay, I need a virtual machine, and decide, okay, what kind of virtual machine you need, how much RAM you need, how much CPU you need, and then the portal, self-service portal, will automatically spin and create a virtual machine for you in just few minutes. So that became a super hit program inside Amazon, and that was the, I would say, that was the seed for the growth of AWS. That was a simple idea which started, and today it's a close to $40 billion organization, AWS alone, which is the cloud service of Amazon. So what they started is with IaaS, which is infrastructure as a code, infrastructure as a service. Sorry, infrastructure as a service means any infrastructure you need. It can be, okay, I need an Oracle server. Okay, then what you can do is you can first automatically spin up a virtual machine on Amazon AWS, and then you install Oracle on top of it, right? So infrastructure is managed, so the virtual machines are all managed. All you need to take care in infrastructure as code is your own software. It can be you install a web application, you install a database like Oracle. You are worried about only installing the software or the database that you are using or the web application that you're using. That's the infrastructure as a code. That was a starting point of all the cloud journey for AWS. As they became matured in this virtual machine and giving you access to the networks, they started providing services which is PaaS, which is like platform as a service. So what is an example of platform as a service? In my previous example I gave you, I will get a virtual machine created on Amazon AWS, and I will go and install a web application or I'll install an Oracle server, right? That was my example. What was your work in that case? You had to install Oracle server, for example, right? With PaaS, what they said is, okay, Oracle database is, everyone needs Oracle database, or everyone needs SQL Server database, or different types of database. So they decided, let's provide platform as a service as a new offering on the cloud. That is exactly what PaaS is. So with PaaS, what you end up doing is, you go and say, I need Oracle as a database, and I'm not worried about anything. I just tell I need Oracle or database on the cloud. And what Amazon PaaS service does is, basically it has pre-processed services like Oracle RDS, like the SQL Server RDS, MySQL RDS. Many varieties of databases are there. So you'll only mention what you need, and the service will automatically spin up and install the software also on that. Example of that is, as I said, RDS, which is relational data store using Oracle SQL Server, or it can be EMR, which is a big data cluster provided by AWS. So it can be a server like Redshift, which is a massive parallel processing database like Teradata, which is also a PaaS service. Okay, clear? Are you clear with PaaS service? Any questions? Okay, I'll take that is clear. So you don't need to worry anything in the PaaS service. Everything is installed for you. Everything is functioning for you. You don't need to manage. Now, if there is an upgrade of Oracle, example, right? Oracle 11G to 11G to 12G, right? It's not your headache at all. Uh, the the PaaS service would provide you the version. All you have to do is choose the new version and upgrade it with one click. So any infrastructure management or services is not your headache at all. That's the best part of PaaS service. You only worry about your own business requirement, how you're going to solve, and how you're going to store the data, right? So that's a big headache out of your head, where you're not worried about many of this infrastructure management that you would need on in your data center, right? So when you compare with your data center, you need a DBA who will install Oracle, who will be monitoring the Oracle as well 24 by 7, and he will take backups, and he will do a lot of activities like, if it's the load is too high, if he wants to increase the RAM, then he has to get a downtime from you guys who are running the application, install the RAM and scale it up. It will take 3-4 days. Now with the PaaS service, you can do all that in few minutes, and we'll be covering those in demos as we move forward. And the backups can be done automatically with PaaS service. All you have to say 24 hours, 12 o'clock in the midnight, take backup, and it will be done. To be honest, in Amazon, when I was working, we had a data engineering team of 40, and we didn't have a single DBA. That's because PaaS services we were using, and it's everything was automated there. The full control was with us, and we didn't outsource any of the requirement as well. And with that, we were able to bring agility and only worry about solving a business problem. So we'll be covering, as I said, a lot of great features in PaaS with different services that we have. And it's at the end, it's just removes the entire management headache from your project. The final one is SaaS, cloud hosted application. So a perfect example for this is salesforce.com. So you want to manage your CRM, which is your customer relationship management, and you don't want to build web application, or you don't want to host web application. All you have to do is go and get an account and get into salesforce.com, and just serve and store the data. They will manage your data, they'll manage your infrastructure, they manage the software as well. Everything is outsourced there. All you have to do is just use the software as a service on the cloud, and yeah, keep building your solution. So that's the last part, which is the software as a service. Okay, so it's completely taken care by the cloud service, and all you have to worry about is, yeah, run your workflows or manage your CRM accounts, and customers are also going to connect to the CRM software, so everything stays there in the SaaS world. Any questions before I move to the next slide? Okay, let's talk about AWS. So AWS is a top leading public cloud from Amazon. We already know that now. It offers 175 services across the data center globally. So it's a huge list of services that is available on AWS for every single thing you can think of. Example, if you think of machine learning, and if you think, okay, can I go and use a service which can recognize the images which I'm going to show to, and you have image recognition to PaaS services on AWS, we can do that. Okay, can I translate my language? Yes, you have services. Can I create a chatbot on my website using AWS? Yes, you have a service to do that as well. Bot services are there. So it has so many varieties that I don't think there is, I would say, hardly anything that AWS cannot do today. So, and that's why it's so famous, and it's number one because it provides you the vast variety of services on the cloud. You can solve any business problem using the different services, and if it's a PaaS service, as I said in the previous slide, you don't need to worry about how to manage them, how to upgrade, how to install. Nothing is your worry. All you have to do is use those services. AWS has significantly more services and more features within the service, and then you have other cloud providers, and then you have you have infrastructure technologies like compute, which is like running your jobs or virtual machines, big data clusters, storage like S3 Glacier, and multiple other other storage services are there. Then you have databases of different varieties, and it's machine learning, artificial intelligence. You can build data lakes and IoT as well, right? So if you are streaming data from your smart devices, it has an IoT gateway, and you can connect to that and bring real-time data as well. So as I mentioned, AWS is the leader in the Gartner's quadrant. You can see clearly. And on the right hand side, you see the different data centers. The orange ones are the ones which are getting launched soon or on progress, and the blue ones are which are already present, right? So you have like close to 25 data centers across the region. So why this is important? AWS provides regions, and they are associated with your account. So example, if your customers are sitting in US, say example, they are in the West Coast, they are in California, then it's good to choose a region close to the West Coast, which basically helps you be close as a data center to the business folks who are using your application, so the latency is removed out, right? So that's a very important thing to understand in any cloud provider, because it has across regions data centers. It's always good to be close to the business users, so that the latency of anything like job or reviewing a report like a BI report in Power BI, the data sits close to them, then the performance or the latency is reduced, and they get a quick response time, and it's really helpful as well. And there are many other solutions. If your example, if you say my customers are spread across the world, where do I do what do I do then there are many other ways to solve that problem also, which we'll be discussing further as well. Any questions? Okay. So VPC and EC2, the following. So what is VPC and EC2? This is what we'll be covering. This. So these are the building blocks for AWS, and I can guarantee you, if you learn this or you understand this concept, you can apply this to Azure or Google Cloud, GCP, any cloud. So if I have worked on all the three clouds, and I started with AWS, but what I've learned is the services are the same across. So the names would change, but the basic infrastructure or how a cloud is set up remains the same across. So that's why it's very, very important for you guys to understand this very clearly. It can be a little difficult to follow in the beginning, and that's why I want you to ask more questions if you don't understand, and may pause me and ask questions and get clarified. Once you learn this, you would understand all the PaaS services, how they work. You'll understand even Azure also, if you end up using Azure later on, or GCP as well, right? So these are all the basics of fundamentals of cloud that everyone should be very clear with. So what we are going to discuss in this slide is two things: VPC and EC2. So VPC stands for virtual private cloud. So what is virtual private cloud? It's nothing but a dedicated network, which is a virtual network within your AWS account. So what's AWS account? Okay. So in your organization, you will launch an AWS account. Then within your AWS account, what you will have is you'll end up having multiple virtual private clouds. So example, let's take an example. You are part of finance team, or you're part of operations team, or you're part of HR team. Every team will have their own VPC because they want to get isolated and work and build their own software services or solutions, right? So there'll be multiple virtual private cloud which will be part of your account. Okay, what this basically does is, you can imagine like in your own data centers you have, how do you connect your data center from your laptop? Everyone is working from home. You need a VPN, right? You need a VPN to get into your data center because you are logging into your network, right? So just like your organization has a dedicated network and it has uh, the only way to enter is through a VPN. Similarly, that network, the zone of network that we are talking about, is on the cloud. That is what virtual private cloud is all about. Okay, now I gave an example of multiple departments will have their own VPC. Like example, if you're part of finance, commercial, or you're part of operations team, or you're part of a business unit like HR, you will have your own VPC. And then how does VPC get segregated between different teams? So example, if you're part of finance team, you might have account receivable, account payable, and different other departments within finance. So those teams can also get segregated and have their own dedicated network. That is what subnet is. So as the name says, subnet, you're dividing your network into different IP addresses, and that's inside your VPC. So we'll see a diagram after this which will make things more clear, but at least at high level just try to understand and remember these words. The route table, now because you have divided your virtual network into different subnets, how does the network request flows between the subnets? That's what route table actually helps you do. So it basically is a network traffic monitor and network traffic router, as a route is something that helps you route the different network traffic. Then you have internet gateway. So internet gateway allows is attached to a VPC, and it enables the communication of your VPC with an internet, right? So internet gateway is straightforward. The name itself tells. So if your VPC, which is your virtual private cloud network, needs an access to internet, then you attach an internet gateway to the VPC, which we'll be seeing in demo also. So don't worry much right now. EC2 Elastic Compute is the most important service, and this is where everything started. I think I gave you the story of Amazon, right? So if anyone needs a virtual machine on AWS, you can do that in just few clicks, and it will take you like few minutes, like 3 to 4 minutes, to get your virtual machine up and running. It's as simple as that, and you'll be able to self-serve yourself as well once you have the AWS access. So how does it look? The different services. So the topmost is AWS account. That's what you see here. So it's saying account A, and what you see on the top is the AWS account, and within the AWS account you have one VPC. I'm keeping it very simple, so you can have multiple such VPCs in your organization later on. Then what you have is a subnet. This is what you see here in the box. Can you see my pointer?
Yep.
Hello, you can see? Okay.
Yes, yes, yes. Yes, yes.
Okay, so and then you have the subnets. There are two subnets. If you see one, this rectangle box, the whole big box outside, and then you have another subnet here. It says public subnet, and this one says private subnet. So there's a different subnets available, which we'll be discussing next. Now, what you end up seeing is this part is a route table, which I said it's a router. So any request that comes, let's take an example, right? So this is EC2 box, which is a virtual machine. Example, this is a virtual machine which has a web application. This is a virtual machine which has a database, and this is a virtual machine which has, say, it has a reporting server. So when a request comes, if it is a customer who is accessing to a web service, then the route table will route it to this box because the IP address or the the DNS name with the request would be pointing to the EC2. So this route table basically helps to route the request based on what's coming from the outside world, right? If you see here, there's an internet gateway, and this internet gateway is actually connected to this subnet. So when you attach a internet gateway to a subnet, then it's called public subnet. Okay, why it's public? Because these services are now accessible from your internet as well. That's why it's called internet gateway and public subnet. So example, I installed a Oracle database on an EC2 machine, and I want this Oracle database to be accessed by my clients or my customers across the globe. They don't need a VPN to come in. All they need to do is connect to this EC2 machine DNS name or the IP address, and you use a JDBC connection and connect to it from anywhere in the world, right? That's what, because it's connected to the internet now. That's what the public subnet is all about. Okay, there can be a scenario when I have built a web application and I have built some configuration tables, and that is holding inside a database. These are not public information. This is only specific to my projects. Like I'm storing metadata, I'm storing my configuration tables, all those stuff into, or I'm storing some important customer information like a customer payment and etc into a database like RDS or into a machine like EC2. I don't want this machine to be exposed to the internet because it's my own data. I'm processing it for my own usage. It's just for my own internal application and consumption. To secure your data, you will use a private subnet and not expose these services to the cloud. So it means this sits inside your VPC. You can access these services only when you log in and get into the VPC. It's accessible only to you as an account user. It is not having a public endpoint or a public IP address, so nobody can access from outside the VPC. That's what the private subnet is, and it's very important feature for providing security. Any question? I'm sure you should have question at this point of time. So please let me know what do you understand this, or what is not clear.
Yeah, so Nitin, I do understand that private subnet. So because this
No,
private
so can
subnet,
you be little loud? I think I'll.
can you hear me?
Yes. Yeah. Please go ahead.
So I was saying that this private subnet might need to be accessed from public subnet.
Very good
So
question. That's a very good question. So yeah. So let's take an example of the deployment architecture, right? Suppose this is an EC2 box which is hosting Amazon.com. Okay, what do you do at Amazon.com? You log into your web page. Everyone has access to Amazon.com. So that's why we'll put that into this EC2 machine, which is virtual machine, and it is in the public subnet because I want Amazon.com to be available on the internet, right? So you launch Amazon.com from your browser and you're able to connect because the request flows in here and it gets access to this EC2 box, and Amazon.com page is displayed to you. Clear? Now Amazon.com would have a lot of what you see on the screen is a lot of different catalog which of products. It's a catalog of products, like there are multiple catalogs that are the products which you see on Amazon.com. So those are all, say, examples stored in this database, but it is in the private subnet. Now it's a very good question. This is my web application, which is Amazon.com, but I need the all the product images and the product descriptions which are stored in my database here. How does it work? So that's where again the routing table works. So the EC2 machine here would be connected to this database, which is an RDS database in this example. It will be connected using private IP address. So when you have a service on the cloud, they have two kinds of IP addresses. One is private IP address, another is public IP address. Okay, I'll go very slow. Public IP address is something which is available for everyone to access on the cloud. Private IP addresses are available to be accessed within the VPC. So only within the VPC. So example, this EC2 machine wants to connect to this EC2 machine, or it connects to this RDS machine, there is no public IP address because it is in the private subnet. So it will have only one kind of IP address, which I'll show you in the AWS console also, okay, when we are doing the demo in the next few minutes. So the communication between these two services using private IP address. So when I say private, it means the network packets are never left, never leaving this AWS network. They are within your network. Okay, that's how you would communicate. So this EC2 machine is inside a VPC. So it will say it will hit the IP address, the private IP address of this database,